In this video, I'll show you how to solve the ALEKS problem called stoichiometric coefficients. This problem is going to be asking us to count up the total number of potassium atoms on the right-hand side of the equation. So first thing we want to do is find the arrow and focus our eyes on the right-hand side, and I'm actually just going to cross the left-hand side out so we don't get distracted by it. So we've got potassium atoms in a few different molecules on the right-hand side. We've got a potassium right there, we've got some right there, and we also have some right there. We want to make sure that we count all of them. There's going to be two things that we're looking at when we're counting up these potassium atoms. First thing that we want to be looking at is the small subscripts next to the potassium, if there is one. In this first molecule, there is no little subscript after the potassium, like there's a 2 here. There's no little subscript here, and that just simply means that we have one potassium atom in that particular molecule. In the second one over, we've got a little subscript of a 2, and that little subscript 2 is letting us know that we have 2 potassium atoms in that molecule. And in our last example here, we have, again, no subscript, which means that we have in that molecule only 1 potassium atom. So we can add all of those up, and that tells us that we've got a total of 4. Now, I said that there are actually 2 things that we want to be paying attention to, but then I only talked about one, the little subscript, and that is because that was all that was featured in this particular problem. Sometimes there's something else that we have to pay attention to as well, and that would be a larger number that comes in front of the molecular formula, like in this example right here, 4KOH. So this is not a subscript, this is a big number. This big number is the stoichiometric coefficient. And if you have a large number in front, basically what you want to do is multiply that by the total number of atoms in each molecule. So let's pretend, just so that you can kind of get an example, let's pretend that we had, instead of K2CO3, we had 4 K2CO3. So pretend like there was a 4 in front here. This, if we had that, which we don't, but if we did, we would say, first of all, the subscript is telling us that we have 2 potassiums, and then, second of all, that 4 is telling us that we need to multiply that by 4, multiply the 2 by 4, and that gives us a total of 8 potassiums in that molecule. Now that's not what we have in this example, so I'm going to erase it so it's not confusing. In this case, we only have 4.